Hello everyone, my name is Berk Erhan Yüksel. Today I'm going to answer the questions of experiment 4, which name is the magnetization curve of separately and at self-excited DC generators, and the answers of experiment 5, which name is speed control of DC motors. Okay, in the first question, we have a parameter that is denoted by IP, ingress protection rating. Ingress protection ratings or IP ratings refer to the level of protection offered by an electrical systems or machines against the solids like dust and liquids like water. The IP number consists of two numbers, as you can see. In this experiment, we have 5 and 4. The first number denotes the solid protection level, and another one denotes the water protection level. Our motor has IP54 requirements. As you can see from there, IP5 means ingress of dust is not totally prevented, but dust does not harm or get damage to the system. And the second number is 4, and it denotes the low pressure spray similar to the shower head. Therefore, water splashed against a machine from any direction have no harmful effect at the motor. Of course, these tests can be done in 5 minutes by using 10 liters water per minute and using 80 and 100 kilopascal water. In sum up, our DC machine is protected against the dust and water. In the second question, we examined the open circuit tests. In these tests, we have seen the relation between field current and back EMF. However, although we adjusted our field current to the zero, we have back EMF approximately 4 volts. Since we have residual magnetism on the system, as you can see from the magnetization curve or called hysteresis loop, if we decrease our current to the zero level, as you can see, we have flux 1 on the graph. This flux generates residual magnetism, and we have 4 volt back EMF approximately. From field current and flux or back EMF graphs, this can be easily seen. See this relation and the underlying reason of this phenomena by explaining the residual flux or residual magnetism on this system. If we look at the third question, when the field current decreases, the rotational speed we make increases. They have inversely proportional relationship in this experiment. If we examine the back EMF formula, as you can see, we can see this relationship easily. In this experiment, we have constant back EMF EA and constant machine constant KA. In addition, we can write the flux equation in this back EMF. We can write the flux equation is equal to field constant multiplied with field current. Therefore, if the field current decreases, the flux starts to decrease. In conclusion, if the flux is decreased, the rotational speed we make start to increase because of constant back EMF. If the flux is decreased, these are constant. If the flux is decreased, rotational speed must be increased to hold this equation. So the rotational speed inversely proportional with the field current. In the fourth question, when the armature voltage is decreased, the rotational speed decreases too. This can be explained by using back EMF formula, like we did in the third question. In this case, we have constant flux and constant machine constant, as you can see. If we decrease the terminal voltage, the back EMF voltage is decreased too. VA is decreased and back EMF is decreased. When we look at this formula, Ki and flux is constant. If we decrease the terminal voltage, the back EMF voltage is decreased and Therefore, V mechanical rotational speed must be decreased also to hold this equation. On the other hand, if we increase the terminal voltage, the rotational speed increase also. They are proportional with each other. And by looking this graph, the relationship can be seen easily. If we increase the terminal voltage or armature voltage, the mechanical is increased proportional.